So this video is going to cover sections 2.5 of Focus on Linear Functions. And a great deal of this should be a review for you, so I think you'll find this a nice refresher in terms of the value of this section as you work through this unit. So Focus on Linear Functions, we're going to fill in a couple blanks using what we just did in section 2.4. In our previous section, we learned that a linear function has it was that last example in section 2.4, a linear function has a constant rate of change. It's always the same value. For a linear function, the rate of change and the average rate of change are always the same, are equal. And the last piece, and the one that really helps us, the rate of change, the average rate of change for a linear function is equivalent to the slope of the line when it's graphed. And so we're going to work through the concepts of graphing functions that are linear, understanding slope, understanding the different ways in which we can write the equation for a line. But to do that, we're going to go through a whole bunch of statements, and I'm going to get rid of a little bit of the suspense here. Every one of these statements that you're going to see is true. Statement 1, if we can draw the graph of a line, we can define its equation. We'll see more about that in a couple of moments. If we're given 2 points on a linear function, we can certainly draw and graph the line. All we need to do is what? Connect those 2 points, and we have a line built. Remember what we always say, the shortest distance between 2 points is a straight line. You got 2 points, you can connect them with a straight line. If we're given 2 points on a linear function, we can compute the slope of the line. Absolutely true. Look at your change in y over your change in x. When you look through those 2 points, you have exactly what you need, the slope of that line. If you're given a point and the slope of a line, you can graph it. You can put that down on paper. Again, a true statement. As soon as you have 1 point and a slope, you know a change in y over change in x. You know how to go from 1 point to another just using the slope of a line. If you're given the x-intercept and the y-intercept of a line, you can graph the line. Absolutely true. Remember and write this down, and we'll see it in a little bit, in a sec, but we'll repeat it right now. The x-intercept and the y-intercept are always points. They're not numbers. X-intercept is a point, a y-intercept is a point. So if you know the x-intercept and y-intercept, you know 2 points on a line, just like what you saw above. You can draw and graph that line. Slope-intercept form is the most common method to write the equation of a line. Absolutely true. Y equals mx plus b. We've used it all the time. The location of the x-intercept and y-intercept of a linear function are written as single points. That is correct. Again, remember, they are points, not numbers. The y-coordinate of the y-intercept corresponds to the value of the linear function when x equals 0. Absolutely true. Plug in x, you will get the value of y, and you'll graph the point 0, comma y. It'll be on your right on your y-axis. That's the y-intercept. The x-coordinate of the x-intercept of a linear function is the value of x that sets y equal to 0. It'll live on the what? X-intercept will live on the x-axis. What do you know about the x-axis? The y-coordinate is equal to 0. A vertical line has an undefined slope. Absolutely, positively true. Vertical line, you cannot compute a change in y over a change in x. A horizontal line has a slope of 0. Absolutely true. What do you know? The change in y is always equal to 0. No matter what change in x you do, the change in y is always 0. Change in y over change in x will always be 0 in that case. A line with a positive slope moves upward as we head from left to right. Absolutely true. A line with negative slope does what? It goes down from left to right. As we move from left to right, a line with a negative slope will go down. The rate of change of a linear function is equivalent to the value of m from the standard slope-intercept form, y equals mx plus b. Absolutely, we said that up here. Rate of change in a linear function is always equal to the slope of that line that you can graph for that function. For a line written in standard slope-intercept form, y equals mx plus b, the point 0, comma b is a point on the line. Absolutely. By the way, that happens to be the location of the y-intercept. So, one last term that we'll work with, the initial value of a linear function is the value the function takes on when x equals 0. In other words, it's the y-coordinate of the y-intercept. Set x equal to 0, evaluate the function. That's going to become the point that you put where? It lives right on the y-axis. So just make note, also, if you're in slope-intercept form, y equals mx plus b, What do you know? Well, if you plug in 0, you're going to have y equals m times 0. That goes away. Plus b. You walk up with a value of b. So you know for a fact, if you have something written in slope-intercept form, y equals mx plus b, you know that the point 0, comma b is the location of the y-intercept. And that's why we call this slope-intercept form. You'll see as we go to the next page. So there's three ways in which you can look, three different ways in which we can represent the equation of a line. Slope-intercept form, standard form, point-slope form. And so we have three equations here. You're going to find out that they all represent the exact same line. Here's slope-intercept form, y equals 2/3 x minus 1. mx plus b, hey, m is equal to 2/3. This line has a slope of what? 2/3. I also know what? Minus 1, I know my value of b equals -1. And from our prior page, if we plug in 0, I know 2/3 times 0 minus 1 gives me -1. I know that 0, -1 is a point on this line. Now I can very quickly, if I want to, just to find another point, why don't I let x be equal to 3? If x is equal to 3, 2/3 times x, 2/3 times 3 becomes 2 minus 1. That's going to give me what? A value of y equals 1. So I have another point on this graph. So 3, 1, 2, 3, 1. Can I now graph this? Absolutely. Connect, and there goes my line, and I've graphed this perfectly. All right, slope-intercept form. There's your basic pieces or whatever. As soon as you know one point in a slope, you're set and free to go. Another way in which we can represent a line is in standard form, where we have our constant term on one side, and then everything in terms of x and y sit on the other side. So simplest way to describe it is get all your x's and get all your y's on one side, leave your constant number on the left side. 2x minus 3y equals 3. Now, why do they call this standard form? Well, standard form allows us to compute two intercepts very quickly. Let's let x be equal to 0. If x is equal to 0, let's solve for y. 2 times 0, 0. So I'm going to have -3y equals 3 when x equals 0. How do I solve that? That would require that y be equal to -1. I've just shown that 0, -1 is a point on this line. I still can't see a slope here or anything, but what can I do? Well, I could go ahead and set y equal to 0. If I set y equal to 0, I would have 2x equals 3, which would tell me that x is equal to 3/2. So I know that 3/2, comma 0 is another point on this line. So here I go over 1.5 and right at 0. There's a second point, and I can build my line. And by that way, those lines are the same. Now, so our last piece to handle is something called point-slope form. Point-slope form requires you to know the slope and to know a point on the line. The form is y minus y1 equals m, the slope, times x minus x1. And the y1, x1, those little subscripts you see there, that's the location of a point on the line. The form that we have, y plus 3 equals 2/3 x plus 3. If I follow this format, well, I know what? My y1 better be a -3. Y minus a -3 is going to look like a y plus 3. And I also know that what? I got an x plus 3 over here. My x sub 1 better look like x minus -3, so that it can look like what? The x plus 3 I see in the equation. So I know that the point -3 is on the line. 1, 2, 3, 1, 2, 3, and I've dotted it. Now, I also know the slope, so I can do a couple different ways to go ahead and find another point. I could do a little bit more substitution. That would be fine. For instance, if I let x be equal to 0, I would have what? I would have a value of 2 here. If x was equal to 0, I'd have 2/3 times what? 0 plus 3, 2/3 times 3, an answer of 2. How do I make y plus 3 equals to the 2? Y better equal -1. And lo and behold, I just see, here's a point, 0, -1. It fits perfectly with this structure. Connect the line, and away I go again. And the point is, each one of these different representations, these equations all look different for sure, but they all give us the exact same line. There are different ways to represent the equation of a line. Slope-intercept form, you know the location of the y-intercept. That becomes your value of b in the equation because you know that point, 0, b is on your graph. You know what your slope is. You can build. Standard form, what does it give you? ax plus by. And what can you do on each side? You can find the intercepts. Set x equal to 0. You can find out the value of y. You get the x-intercept, 0, whatever. You can set y equal to 0. Find out what value of x makes this function work. You get the two intercepts. When you have the two intercepts, you can go ahead and do what? Draw a line right through it because you have 2 points. And similarly, well, when you have point-slope form, you already have a point given to you. Just read the formula and you know exactly the location of one point. And then you can just kind of plug and play or use your good old rise over run capability to go ahead and get one more point. Remembering again, when you have 2 points, you have everything you need to draw a line. So again, all these forms are useful. You maybe will find one that you prefer, and nothing wrong with that. Work with the one that you like the most. There will be a couple times where maybe we're going to ask you to convert from one form to another. So you are going to need to be aware of the different representations. So a couple other quick points just before we move into the gist of the lesson, and we'll work with some problems in a few moments. But just to wrap out a few more things. If you want to move from slope-intercept form to standard form, all you need to do is move all the constant terms on one side, or the constant term on one side, move x and y onto the same side. It's preferred that a and b are integers. Doesn't have to be, but it's preferred that you'll have something that looks like 2x minus 3y equals 3 as opposed to 5/4 x minus 3/8 y equals 7 or something of that nature. You would like to have integers, but it's not necessarily required. In simplest form, integers work pretty nicely for you here. To move from standard form to slope-intercept form, all you need to do is solve for y. Get the x back over to the other side, solve for y, and you walk right into slope-intercept form. And a couple other things that we want to remember. Parallel lines have the same slopes. The slopes of perpendicular lines are related as negative reciprocals. Take the slopes of those two lines that are perpendicular to each other. When you multiply those two slopes together, the negative reciprocal means you will get -1. So if you have a line with a slope of 3, the line that's perpendicular to it will have a slope of -1/3. So again, just recall, parallel lines, whatever they happen to be, same slope. Perpendicular lines, when you multiply those two slopes, you're going to go ahead and get -1. And now we'll work through some examples.